For my third video for solving radicals, we're going to be looking at ones now. The previous two resulted in linear equations. These next couple will result in quadratic equations. So we're going to have to deal with quadratic equations, but the steps still are the same. Make sure your radical is isolated, raise both sides to whatever the correct power is. In this case, it's usually going to be squares. We may now, for quadratics, we may sometimes need to use an area model, so we'll get into that. And then we solve using factoring or the quadratic formula or whatever you like to use for solving quadratics. And then we, especially now with quadratics, we're going to need to check our solutions. So, looking at number 5. All right, my radical is isolated. There's nothing over here with it, so that's all good. We'll have an example in a minute where we do have to do a little bit of work when we get down to number 7. But this one's isolated, so we can raise it to the correct power. This is a square root, so I will square both sides. I do advise you, whenever the variable is b, to be really careful that your b's and your 6's look different, because you might confuse yourself. I've seen it happen. You can also just change it to an x. So when we square both sides, the radical falls away, and we get 2 minus b equals b squared. All right, for quadratics, you always want to get them into standard form, meaning set equal to 0. So of course we're using b instead of x, but this is the format that we want. We want to get our quadratic term, our linear term, and our constant term all on the same side of the equation. And because I'm going to be solving by factoring, and I really don't want my first term to be negative, I'm going to look for where the quadratic term is, and I'm going to move everything to that side. All right? So even though there's just one term here, and you might think, oh, I'll just subtract b squared, it's going to be easier in the long run if you move things towards the quadratic. All right, so I have a negative b. I want to add b to both sides, so that goes away. I have a positive 2, so I want to subtract 2 from both sides, so that goes away. So my quadratic now is b squared plus b minus 2 equals 0, which is set up in standard form. You could solve this by quadratic formula if you choose to. That's just going to be negative b plus or minus square root of b squared minus 4ac over 2a, but you can already see we might get confused because we have b's here and we have b's here and they're different. So personally, I'm going to use factoring because these are nice, easy, small numbers. So I'm going to go for factoring. I know that I want numbers that multiply, a pair of numbers that multiply to negative 2 and add to give me my middle term, which is just, if there's no number here, remember that's a 1. So some people set it up like this. That's totally fine. I personally like to set it up using a table because sometimes I wind up having to come up with multiple pairs of numbers that multiply to my last number before I find the one that adds correctly. In this case, though, it's pretty straightforward. This is going to be a 2 and a negative 1. That multiplies to negative 2 and adds to give me 1. So that means this becomes b plus 2 times b minus 1 equals 0. Because I don't have a number here, I don't have to do the area model to factor. I can just pop them right in. When I'm solving, I set each one of these equal to 0, and I would have to subtract 2 in this case, so this is going to be b equals negative 2. This one gives me b minus 1 equals 0, and if I add 1 to both sides, I get b equals 1. So I have 2 solutions. Quadratics oftentimes give you 2 solutions, but I haven't boxed either one of them up because I don't know if they're valid. So what I'm going to have to do now is check them. So I've run out of room. I'm just going to pull up an extra sheet of paper here. You guys are welcome to do work on your own paper. You don't have to try to fit it into this little space. So my original equation, see, I've been checking in red. So my original equation was 2 minus my variable equals my variable. So I want to know, is that true? And I have to actually do it twice because I have two different values. So I'll go ahead and set that up. 2 minus my variable equals my variable. All right, so over here, I'm going to plug in my -2. -2 there and there. I plug it in anywhere that I have a variable in my original equation. So let's follow that through. 2 minus -2 is square root of 4 equals, I don't really need the parentheses here, this is -2. So is this a true statement? Well, no, it's not, because when you take the square root of 4, you get 2. Is 2 equal to -2? No, it is not. So this is what we call an extraneous solution. So back on my paper, rather than drawing a box or a circle around this, I'm going to cross it off. That one's no good. All right, I'm going to do the same thing with my other b value. So I take my original equation, 2 minus b under the radical equals b, and I'm replacing b with 1. So 2 minus 1 is just 1, and I don't need the parentheses here. So is that true? Yes. The square root of 1 is just 1. 1 equals 1. That works. So in this case, I found two solutions, but one was extraneous and one is good. So I cross off the extraneous and I keep the good one.